Yep. Okay, so today we're going to talk about the intermediate value theorem. It's something that's pretty intuitive. I don't think you'll have a tough time with it. I don't think you'll have a tough time with it. And what the intermediate value theorem says is, suppose we have an interval of a to b. Let's have an interval of a to b. Now let's have a function that defines a value of f of a and another function that defines a value of f of b. And what it says is, if the function is continuous, then it's going to have to cross over every y value between f of a and f of b. And here's how it says it, okay? It says, pick a number n that sits between those two. So let's say we pick a number n that sits between those two. It says at some time, if you're going to connect those black dots, you're going to have to cross over that green line. Do you agree?
I agree.
Okay, so let's try to do it and not cross over the green line. Okay? So I'm going to come up here. I'm going to get really close. Woo! And I'll bump back down, and then I'll do this thing. Look at that. Now that does not satisfy, don't draw that. That does not satisfy the mean or the intermediate value theorem, because the intermediate value theorem starts off by saying that the function is continuous. Is that a continuous function?
No.
No. So it's not referring to that type of example, but I didn't cross over n there. Okay, and then here's another example. I'm going to try to not cross over n again. Aha! Look at that. Yeah. Tricky, huh? So that fails on multiple counts. First of all, it does cross n over there, doesn't it? And furthermore, that's not a function anymore, is it? No, it's not. So if we really try to do this, if you're gonna start here, but you want to get to that spot, then you're gonna have to cross over at some time, aren't you? And so the intermediate value theorem says, let f be continuous on AB. So let f be continuous on AB. So that just means a continuous function on that interval. Then let f of a be less than or equal to n, which is less than or equal to f of b. So n sits somewhere between a and b. Okay. N? If you want to, you sure can. The IVT, intermediate value theorem, IVT is something that you will reference when we start preparing for the AP exam. The intermediate value theorem guarantees a value C such that A is less than or equal to C, which is less than or equal to B, and f of C is equal to n. Yep. Okay. So this doesn't seem to make sense. For those of you who are considering a little bit higher level of mathematics someday, this is what you get used to doing all of the time. And you get used to reading it and actually makes sense to you. So this is part of what we kind of leave out from time to time in our other stuff. Because this language is confusing, I left it out of our other tests. You are going to be able to spend time both on this one and our next one, 4.2, seeing this and be able to apply it a little bit better. Here's all it means, okay? N is between these two, agreed? So there's some x value, c, that sits between a and b, such that if you plug in a function, you get that n value. Now, suppose you changed n. Suppose it was here. Well, then all of a sudden, your c value is there. Doesn't matter where you draw. Now my smartboard is getting angry at me. Doesn't matter where you draw n, you're going to find a c value that sits between a and b that will correspond to that. Yep. C value is the x value that will give that output. Okay? You do not need to memorize that, okay? But what you do need to do is you need to know this. It says, explain why the function has a 0 over the given interval. What does it mean for a function to have a 0? It means that the function somewhere is equal to 0. So we want to show x cubed plus x plus 2 is equal to 0. Okay? Now, solving that's difficult. Does anybody know how to, that doesn't factor, does it? Doesn't factor at all. Okay, and the rational roots theorem looks cute. Fortunately, it does work, but we won't talk about that at the moment. We'll just show that it has to have a 0. And here's all we have to do. We're going to find out what f of negative 2 is. Where did I get negative 2? Yeah, that's my first. This is not a coordinate. This is a interval. So this is the first x value. That's the second x value. So we want to say that this thing is equal to 0 somewhere between negative 2 and 1. So all I do is I plug in negative 2. What do you get when you plug in negative 2? Negative 8 minus 2 plus 2 is negative 8. Now I'm going to determine f of what? 1. Okay? What do you get if you plug in 1? You get 4. So everybody here could do that, but the question is, do you understand what you just did? Let me show you what you just did. You said that f of negative 2 is negative 8. That means back at negative 2 is all the way down here at negative 8. You had the point negative 2, negative 8. And then you had another coordinate of 1, 4. You plugged in 1, you got an output of 4. Everybody see that? So if I want to go from this spot to that spot, do you have to cross the x-axis? Yeah, you have to. The intermediate value theorem says so. It says you had a negative value and you had a positive value, so you're going to have to cross over 0 somewhere in between. That makes sense, doesn't it? Yeah. Okay, yes. So all you have to do is show you have a negative and positive and say the IBT guarantees B0. Somebody want to guess what IBT stands for? Intermediate value theorem. Let's look at this function. Not quite as clear that that would cross over the x-axis somewhere. We're going to show that it has a 0 over the given interval. First, I'm going to do f of 0. Sine of 0 is 0. Times 3 is? Plus 1 is? 1. So we know it starts at the point 0, 1. Now let's try f of 5 pi over 4. What is the sine of 5 pi over 4? Very good. So we'll talk about it. Michaela sees it. 5 pi over 4 is how many degrees? 225. Good. What is that location right there? Yep. Negative root of 2 over 2. Positive root of 2 over 2. Assign the x value or the y value? The y value. So you get 3 roots of 2 over 2 plus 1. What? Oh, yes. I'm sorry. You're absolutely right. Thank you. Bad job there. Bad job. Thank you. 225 degrees is here. Yep. Yep, so negative 3 roots of 2 over 2 plus 1. Let's see what that is. I'm going to take out my calculator and produce a decimal so I can see where it's at. Negative 3 roots of 2 divided by 2. I'm going to add 1 to that, and I get negative 1.12. So if it starts at 1 and it goes to negative 1, does it have to cross over 0? Yes. Is there a different acronym you would like other than IVT?
I'm just going to say IVT guarantees 0. I would just not like to write guarantee.
Okay. So I will say that this is what they want expressed on your AP exam. Lots of ways you could write it. This is what I would say is the shortest way to write it. So now what we're going to do is we are going to show that the IVT does guarantee a 0, and then we're going to find that 0 by using a graphing calculator. So make sure you have your calculator out. I know. Okay. So all I have is I have my function plugged in, and what I would like to do is show that it has a 0 between negative 1 and 2. So all I'm going to do is determine f of negative 1, and I'm going to determine f of 2. So I get to use my calculator. What is an easy way to go about determining these values? Go to my table. Negative 1. And I get a value of 1. Plug in 2. And you get 13. Does it have to cross over 0? No. You had positive to positive. Does it have to cross over the number 6? Does it have to cross over the number 10? Does it have to cross over number 20? Does it have to cross over the number 0? No, it only has to cross over the numbers between 1 and 13. So the IVT...
What if it was 0? Like, that's negative 1 equals 0.
Yep, and then you've actually found the 0, haven't you? The 0 would be at negative 1. So the IVT does not apply in this situation. Does not guarantee it. There might be a 0, but it doesn't guarantee there's a 0. What could I do to see if there is a 0? Yeah, I could look at my graph. I could check it out. And it doesn't cross the x-axis, does it? It doesn't. Okay. Everybody see that? All right. Let's try the next one. What do you notice is different about this function? What about the fraction? It has a vertical asymptote. So you would agree that this is undefined for an x value of -2. So the intermediate value theorem talks about continuous functions. Is this a continuous function? No. But is it continuous over this interval? Yeah, see how -2 is not part of this? Suppose it was from -3 to 2. Then we would say the intermediate value theorem does not apply. But -2 doesn't fit in there. So here the intermediate value theorem does apply. Let's go ahead and plug it in and see what we get. My y equals, I'm going to type in -4 divided by what? Okay. Thank you. Please put in parentheses. These are the mistakes that people make, and you get points off on the test. Got to understand how to type that in. I'm going to go ahead and evaluate -1 and 2. If I type in -1, I get -1. If I type in 2, I get 2. Does the IVT guarantee a 0? Yes, it does. Because I changed from negative to positive, it must cross over 0. Let's actually find the 0. How are you going to find the 0? Good. So I've heard a couple things that are going to work. Number one, I'm going to graph it. And second of all, I'm going to go second, calculate, and what will I choose? I'm going to choose my 0, which is number 2. And it says, find the left bound. I move to the left, and I press enter. And I move to the right, and notice how it crosses over the x-axis. And without a doubt, my answer should be between -1 and 2. Is it? Yep, x is equal to -2/3 or -0.666. So we have found the value that guarantees. Any questions there? Do you see the example and understand how it applies sometimes but doesn't always apply? Okay. All right, last section. Verify the IVT applies to the indicated value of C, then find C guaranteed by the theorem. Okay? So now we have a little bit more information here. It says f of x is equal to this over that interval, and I'm wondering where f of C is equal to 6. So I'm not wondering where it's equal to 0. I'm wondering where it's equal to 6. Let's see if it applies. F of -1. Let's determine that. What is -1 squared? 1 minus 4? -3 plus 1? -2. F of 3. Now I plug in 3. 3 squared? 9 plus 12? 21 plus 1? So, does it have to cross over 6 at some point? Yeah, it does. Does it have to cross over 0? Does it have to cross over 30? Does it have to cross over -3? No. Sometimes people always just look, okay, it goes negative to positive. Suppose that instead of 22, suppose it was 4. Is that enough to guarantee? No, it's got to be a number. We're looking at 6, not 0 here, folks. So look at the number that you're trying to consider. So we've got 22. Great. We're going to find the x value. It's got to be between -1 and 3 that satisfies that. So all we say is, when is x squared plus 4x plus 1, when is that equal to 6? Instead of saying equal to 0, we're just saying equal to 6. What do we do? Minus 6, x squared plus 4x minus 5 is equal to 0. X what? Plus 5x minus 1. What are the two solutions? So which one is the one I use? Do I use both of them, one of them, or none of them? Yeah, what sits in the interval? -5 doesn't sit in the interval, so the answer is x is 1. That's where it sits. Okay, so, Ava, you ready? We're talking about the interval from -1 to 3. So our x value has to be between -1 and 3. Okay, and it turns out +1 is the one that sits, -5 does not. Do you see that now? Good question.
Wait, Mr. Gens.
Yes.
So when you're looking at like which one it is, does it go through the -1 to 3 or -1 to 2?
The -1 to 3, these are your x values. These are your x values. Those are your y values.
Oh, okay.
So the 6 matches with those. Those are y values. These are x values. See that? Okay, we look at the next one. Same type of situation. You would say, what is f of 0? And what is f of 4? And you want to see that they cross over 1. But I look at the function from the beginning, and what do you notice? Yeah, this is undefined for what value? Is 3 in that interval? It is. So therefore, the IVT does not apply. And if you wanted to give a reason why, it would be because it's not continuous over the interval 0 to 4. It's not. Yep, it's continuous everywhere else, but not at 3. Everybody see that? Okay, time to look at your assignment. Look at your assignment. Problem 1 says explain why the function has a 0 over the given interval. Does everybody understand that that is going to map with this example 1? It's basically the same type of thing, okay? If you need to use your calculator to type some things in because you have a cosine and a tangent, that's fine. Then it says use the intermediate value theorem.